Bauert with Zadara.
There.
And you need the clicker.
I need a clicker. Gretchen, did you steal the clicker? Thanks. We get it. Okay. Hi, I'm Mark Bauert. I'm the CEO of Zadara Storage. Our goal in life is to bring enterprise class storage into the cloud and give cloud users the same kind of control and performance over storage that they have in the enterprise. So what's the problem we're trying to solve? It's primary block storage inside the cloud. The problem in the cloud today is you've got this homogeneous pool of storage that everybody shares. It's low cost, low performance drives, and it's extremely low performance and very inconsistent because you and I are writing our data on the same disk drives, which is a security issue. It's also a big performance issue because if I start having a lot of activity, your performance goes down. So it's a security problem. You can't do clustering in the cloud today. And basically, you're not able to control storage to control the SLAs of the applications that you have running in the cloud. So the result is you either have a very bad cloud experience where you upset users or have customers that are upset and therefore have revenue problems, or you're not even able to move to the cloud. So you can't use the economics or the flexibility that you'd like to in the cloud. So what we do, we've come up with a way, a higher level of storage virtualization. We actually allow you to create a virtual storage array rather than just a disk. It's very high performance. We call it a virtual private storage array because all of the elements that you get are dedicated to you. So there's no noisy neighbor. You don't have the inconsistent performance. You can choose whatever you want, and you get that performance to be able to control it. We also allow you to cluster applications. We have a lot of customers today that are using clustered applications in the cloud, and it's secure because you can encrypt your data because it's yours. So we're giving you all of the control where we've got our hero here now he's separated from the masses. He doesn't have to worry about the noisy neighbor, and he can control all of the elements of his storage to match the needs of his applications. And he only uses it for as long as he needs it, and he only pays for it when he's using it. And he can change it because it's all virtual. So our goal is to be able, with our partners, our cloud partners, to be able to address this whole untapped market of people that can't go to the cloud today because of the storage limitations. So how do we do it? Basically, we created a cloud operating system with OpenStack that allows a user to go into a standard pool of commodity hardware and literally build a virtual storage array. So he can choose the controllers, the amount of cache, the type and quantity of disks that he wants. And when he's all done, he gets an IP address and he connects it directly to his instances inside the cloud. So everybody gets the ability to build whatever they need, big, small. They can change it, modify it, and everybody is separated in private from everybody else. So the GUI is basically what you get that shows you exactly what you have on premise. So imagine just taking your storage array from your data center, moving it into the Amazon cloud and using it there. So let's go through a quick demo. So the first thing, you can create a VPSA, you just push it, name it, whoops, name it, and then you can select which cloud you want to build this array into. And every cloud has different capabilities. These are the controllers, different size. We'll build one in an Amazon cloud. We'll select 5 SSDs. Basically that, and basically it's $4 an hour to build it. We've already got one created. This takes about 2 minutes. So now you click on your IP address, and here's all the drives that you built. You now can go in and create a RAID group, just like you could in a regular array. You can decide what kind of RAID levels you want. It can be RAID 1, 5, 6, however you want to do it. Literally be able to build this. You'll be able to see all the volumes that you've created, which you can share among different servers within the cloud, and you get performance monitoring of every little piece of that environment. So you know how fast things are going, what your IOPS are, and latency. So it's a way of changing this whole storage business model. So we're going from physical, expensive, proprietary storage to the virtual world. So our cloud providers can now let a user build his own virtual array that gives him all, whoops, what happened to, so switched, you didn't switch back, sorry. So this is the shift. You saw the GUI, but now the shift. So it's going from a physical to subscription, pay-as-you-go, be able to manipulate it. So our team has been together for 10 years, a lot of startup experience. We're very, very good at enterprise storage, and we're bringing those skills into the cloud world. And it's been a real remarkable year. We started the company back last year in March. By September, we had OpenStack completely integrated into our system. We filed our patents in November. We closed deals and partnerships with top cloud providers. And then we just concluded our beta testing with over a dozen customers testing our system in our environment. And then next month, we're starting our GA. And in fact, our first customer is going to be the National Institute of Health, which is putting the human genome into Amazon's cloud. They needed it for performance and the ability to give their scientists the kind of control that they needed. So what we're looking for is cloud users that want a better experience, people that couldn't go into the cloud. On these, of the three that we're on, investors and cloud providers.
Mark, thanks very much. Good job. All right. Judges.
Mark,
He's not wearing Levi's.
no,
All
two
right,
questions.
sorry.
Points deducted. Bad pants.
I got Levi socks on. Did you
All
see
right.
those?
Two questions. I'll pause between, but I think you're just public clouds today.
Today,
Private
that's the
coming
start.
when?
Yeah, this can work in a private or a public cloud, but our approach is we're partnering with the public cloud guys. We've got dedicated production systems in each of these cloud environments, so we can now leverage the customers that they need to bring to the field. We're leveraging their sales and marketing along with ours, but it also can be deployed in a private cloud.
Yep. So when I call Amazon or whoever, do they? To me, it should be transparent. I don't care. I want the best service as cheap as possible. So, do we influence that? Do we tell them, that we want your product, or how does all that sales cycle work on their end?
So it's a lot of different ways. We've had people that have come to us directly. We sell it directly. So you would buy it from Zadara, just like you'd buy your storage from somebody else on site. We partner with Amazon. They're actually doing some joint marketing with us. They've actually created a white paper to move Oracle RAC into the Amazon cloud using our storage. So it's a partnership, but the actual deal would be between you and I.
Okay. I have another one, but you guys can.
Go ahead.
Quick second one. A lot of big companies putting in-memory appliances out in the cloud, and big data companies like us, huge amounts of point-of-sales transaction. Need real time, et cetera. So, how does all that business intelligence analytics in memory, fit into your vision and your strategy?
So it's effectively, we provide high-performance block storage. So you would connect directly from your compute instance to us, and it looks like an iSCSI target. We've actually had a couple of our beta customers that are using NoSQL databases, which is supposed to get rid of the issue of these transactions, and using faster performance storage like SSDs in the system to be able to deliver faster and better performance. Matter of fact, the National Institute of Health, one of the key things is within this genome, you get a lot of fads where somebody's created a paper and now everybody else wants to replicate it, and all of a sudden you got everybody pounding on the same data. So this is a way in which they believe they can now control and give their scientists the performance they need.
Okay.
So I've got a couple of questions, and the first one is a little bit explanatory. It seems to me you've got three use cases, one of which where you've got an internal application and your solution on the back end for storage.
Internal where? This has to be an application running inside the cloud.
Okay, so you can't run an application inside your firewall, inside your
Data center.
and access your
No, the
storage.
performance, that would be a different
so-
business model.
Right. So the three that I was going to do is inside, but that doesn't work because of performance from cloud to cloud. But that also probably doesn't work for
Actually,
performance.
that does, because you own all the drives. One of the cool things is that if you're in this big pool, your data is all over the place. And so if you wanted to mirror that to another cloud for a DR solution, you just can't do it. In our case, we'll have mirroring that will allow you to mirror the data from the Amazon cloud in the East Coast to an Amazon cloud in the West Coast, or potentially even to a Rackspace cloud for a DR solution.
Okay, and that was actually going to be the follow-on question. So you actually have the ability to go and say, I want to deploy your solution at an Amazon data center on the East Coast and a Rackspace data center on the West Coast, replicate that synchronously or asynchronously, however you choose.
So that's in our roadmap, so that's not here yet.
Okay.
But because we have things like, for instance, the encryption. You have control over those drives, and you know where that data is. So we allow you to encrypt that data, which you can't do in the cloud where your data is scattered all over. And you get the encryption key, and if you decide to leave the cloud, you take it with you, and nobody can read your data. So the mirroring piece is a roadmap item. By the end of the year, we'll be able to literally mirror data between clouds.
So from a kind of a regulatory compliance security perspective, this addresses at least one major concern.
Correct.
From kind of an adoption perspective, what do you think some of the other challenges that you might see from clients that go, okay, that's sufficient, but or that's necessary, but that's not sufficient?
Well, yeah, I mean, we don't solve the hacker problem, I guess, if you're hacking it, but we can actually encrypt data in flight and at rest. So it's a pretty good security solution that we can give you. One of the other cool things about this is because the storage that we're providing you, it's not S3 object storage, it's literally block iSCSI target. It looks just like your system on premise. So if you wanted to move your SQL application up to the cloud, you could do that, and you wouldn't have to change anything because you'd be running it on a compute instance, Linux, Windows, whatever it is, and be able to target that iSCSI array just like you would on your data center.
I think my brain's been corrupted by a year and a quarter over at Citi already, because I can't wrap my head around this because, everything in our world is private, and, the notion of saying, let me mirror this in some public cloud, and then I have to just for disaster recovery purposes, do it all over the place. I can't seem to wrap my head around it. So maybe a repeat of the prior question in some ways. Tell me what's that roadmap to work with companies that strictly have no appetite for public cloud anything? Mm-hmm. What does that roadmap look like? And how would you go about that?
Okay. So the sort of the next phase we're looking at is this is a way of us establishing the product in the market, getting references, showing people how it works, saying, okay, this is good technology. And now it's software only, so we're not doing anything with hardware. We can now license that to someone who wants to build a private cloud. So this is like a private storage cloud. You could actually implement this as a storage solution within your regular data center. Roll in a bunch of cheap commodity servers with lots of disks, run this software on top of it, and now you've got a storage cloud that you could give each of your departments a whole array, self-service, that they could manipulate as they want. Okay. So you get the private cloud. Aren't you excited? I'll put it in Gretchen's cloud if you want.
Needs more red.
You already bought that, right?
Yeah, and I'll wait for my third one.
Lunch is coming, don't worry.
Oh, yeah.
Any more questions? Questions back
Yes.
there?
By the way, Mark, I really like the approach that you showed there. You said block, is it block only? Can't you file?
No, actually, the roadmap, this next generation, or by the end of the year, the beauty of this is the way we do it is through the cloud operating system, we build virtual machines, which now are not servers for you to run an application on, but there are controllers for your array. So we can actually build another virtual machine and run a file stack on that and deliver you an array that can be both block and file at the same time. So you can do iSCSI and CIFS or NFS. Correct. We can even add other things. We actually have a high-performance computing company we used to work with in our old life that wants to put this together and add in some of their software into that controller so they can now make it a proprietary solution for them. So there's lots of different options, but as a startup, we know we have to focus. So we're focusing initially on this public cloud deployment, and let's get that out, and we'll work on.
From a value proposition to the end user, I think it's great because you can dial in exactly what you want from a high performance part, because those are expensive IOs right there, and if you want SSD, buying too much is extremely expensive.
Right, and you can delete it if you want. One of our beta customers, Shoe Dazzle, These guys are delivering a database where they wanted to be able to run a lot of transactions at a point in time. So they literally threw more cores into their controller, gave them many more IOPS, and when they were done with that run, they deleted it and went back down to the original controller.
All right, I got to cut it off here. Mark, good job. Thanks very much.
You're welcome.